Hello my dear students, welcome back to EZEE Notes. Today we'll be starting a new chapter that is nothing but spectrum. So in which we'll be studying deviation, dispersion and about spectrum. So what do you mean by deviation? Deviation means if any light will be passing from one medium to another medium, it will get deviated by some angle, right? This is known as deviation. It changes its path. It's known as deviation. So deviation of light. When a ray of light enters a triangular prism, we'll talk about prism here. It is deviated at the first surface by an angle delta 1 and at the second surface by an angle delta 2. The total deviation is given by, let us see here. This is a prism. Okay. If the ray of light passes from here, this way. Okay. So this will be our normal. This is what? Normal, right? Now, rarer to denser, it will bend towards normal. Yeah, it will bend towards normal like this. So, here there is one deviation, right? Here, there will be one deviation. See, this was the actual path. So, here there will be deviation delta 1. Okay? Now, this is normal to second normal. Now, it will bend denser to rarer, away from normal. So it will bend away from normal this way. Now actual path was this. It bended a bit more. So this will be our delta 2. There are totally two deviations, one at surface 1, another one at surface 2. So therefore total deviation can be written as delta 1 plus delta 2. So total deviation will be given as delta 1 plus delta 2. Okay. The angle of deviation depends on what factors does it depend. In previous chapter we have studied that it depends on angle of incidence, angle of prism and refractive index of prism. Okay. So delta was what? Mu minus 1 into A, I think. We have studied this, right? No. This was minimum deviation. So what is the formula for delta? Delta was 2I minus A. This was minimum deviation. So it is dependent on angle of incidence and also angle of prism. Also delta was equal to mu minus 1 into A. Right. So it will also depend. It is also depend on prism as well, and refractive index as well. As the refractive index depends on wavelength, so deviation also depends on wavelength. Okay, because the refractive index also depends on what? Wavelength. So deviation will also depend on wavelength. And remember, deviation is directly proportional to refractive index. More the refractive index, more is the deviation. Lesser the refractive index, lesser will be the deviation. So let us see. Dependency of deviation on wavelength. Light of different color travels with different speed. We know that. We have studied that, right? So refractive index of glass increases as wavelength decreases. Refractive index mu is inversely proportional to wavelength. As refractive index increases, wavelength decreases. So we can say that deviation increases with decrease in wavelength. Why? Because mu was directly proportional to deviation. We can say that deviation is also inversely proportional to wavelength. More will be the wavelength, lesser will be the deviation. More is the wavelength, lesser is the deviation. So violet light deviates the most because its wavelength is less. That is nothing but least. It has a least wavelength of 4000 Armstrong or 400 nanometer. But red light deviates the least because it has the wavelength, highest wavelength, largest wavelength. That is nothing but 8000 Armstrong, 8000 or 7000 Armstrong approximately. Okay. Next, colors in white light with their wavelengths and frequency. White light is mixture of light of different wavelengths. White light has many colors of different wavelengths. Okay. So if I draw any white light, see like this, we'll see different wavelengths produces different colors. Right? Simple. Different types of wavelength produces different colors. Which colors? Violet, indigo, blue, green, yellow, orange and red. That is nothing but Viebgyor we have studied, right? So white light have these 7 colors of 7 different wavelengths. Okay. So wavelength is the characteristic of color. You can say that color is produced due to change in wavelength. As the wavelength is changing, the color is also changing. Next, from violet to red, wavelength increases and frequency decreases. As the wavelength increases, frequency decreases. Red has the longest wavelength and lowest frequency, but violet will have shortest wavelength and highest frequency. Okay, red has largest wavelength but frequency is shortest. Similarly, violet will have shortest wavelength but frequency is highest. Okay, next, dispersion. Deviation is completed. Now we'll talk about dispersion of white light in prism. What happens? The phenomena of splitting of white light into its constituent colors when it passes through a prism is called dispersion. See, as soon as it passes, what happens? There are many colors in white light, especially these 7 colors we've given, right? Every color has a different wavelength, so every color will deviate differently. As violet have least wavelength, it will deviate the most. See here, violet will deviate most, but red will deviate least. So there will be a spectrum of colors. This band of colors is known as spectrum, and this process is known as dispersion. Splitting of white light into different colors is known as dispersion, and this band form is known as spectrum. Okay. Newton's experiment. Newton showed this experiment. Newton showed that white light is a mixture of 7 colors. When white light was passed through a prism, a colored band called spectrum is formed on the screen. The order of colors is violet, indigo, blue, green, yellow, orange and red. In that form, there was an order of color. This was shown by Newton. Okay. Next, cause of dispersion. Why is dispersion happening? Right. Firstly, different colors have different wavelengths. Just now I told, right, and hence a different speed in glass. That's why they'll deviate least and most. They are deviated through different angles inside the prism. Violet deviates the most and red deviates the least. Okay. Note point. Dispersion of white light occurs only at the first surface of prism. Dispersion occurs only at first surface, not at second surface. Remember that. Dispersion will only occur at first surface. See here, first surface white light, if it goes, it will be deviated. Now again it will get more deviated, right, if it comes out, because they are coming from denser to rarer. It will be away from normal, so it will be deviated more. So remember that dispersion of white light occurs only at the first surface of the prism. Deviation of light occurs at both surfaces of the prism. Deviation occurs at both sides, but dispersion occurs only at first surface. A prism does not produce colors. It only splits the colors already present in white light. It won't produce new colors. It's not like a white color we are giving, there are many colors forming. It's just that the colors present in the white light is clearly shown inside the prism. Okay. Next, PYQs. Okay. When 7 spectral colors passes through a glass block from air, then which of the following statement is correct? Okay, it's asking about speed. So we'll remember Vibgyor. Okay, Vibgyor. Wavelength increases, speed increases, but frequency decreases. So speed of blue and yellow. Speed of blue is greater than yellow. Speed of blue is greater than yellow. No, it's false. Speed of yellow is greater than blue. Speed of green is greater than orange. Green greater than orange. No, false. Speed of violet greater than red. Oh, no, because speed of violet is least, red is most. In speed of orange is greater than indigo. Orange is greater than indigo. Yeah, this is correct. Simple. Just remember Vibgyor. As soon as we go from violet to red, speed and wavelength increases, but frequency decreases. The ratio of velocities of light of wavelength 400 and 800 nanometer in vacuum. Remember, in vacuum, all the colors will have same speed. That is 3 into 10 to the power 8 meter per second. That is nothing but speed of light. They will travel with same speed. So the ratio will be 1:1 only. Okay. The color of white light which is deviated the least. Which will deviate the least? Red will deviate the least. Next, the wavelength range of visible light is 400 to 800 nanometer. 400 to 800 nanometer or 4000 to 8000 Armstrong. Instead of nanometer, it must be Armstrong. Next, calculate the wavelength of electromagnetic wave of frequency 15 megahertz. Frequency is given how much? 15 megahertz. That is nothing but 15 into 10 to the power 6 hertz. Okay. So we need to calculate wavelength. So lambda is equal to C is equal to F lambda. So lambda is equal to C by F. Lambda is equal to C by F. So C is 3 into 10 to the power 8. C is nothing but speed of light. Okay. F is 15 into 10 to the power 6. So 10 power 6 and 10 power 8, if I cancel it will be 10 to the power 2. So 3 ones are 3, 3 5s are 15. So 1 into 10 power 2 is 100 divided by 5. 5 ones are 5, 5 20s are 100. So lambda is 100 meter. Lambda will be how much? 100 meter. Okay, easy. Just a minute. C is equal to F lambda, lambda is equal to C by F. Yeah, right. Lambda is 100. Array. Lambda is 100 meter. Okay. Next, the wavelengths of light of red and blue colors are nearly this and this. That is nothing but 7.8 and 4.8 respectively. Which color has the greatest speed? Which color will have greater speed? Red will have greater speed because more the wavelength, more is the speed. Which color has the greatest speed in glass? Sorry. In vacuum they are asking here. In vacuum, both will have same speed. That is C, 3 into 10 to the power 8 meter per second. But in glass, red will have more speed. Red will have more speed. Okay, remember that. Next, the last question. When sunlight passes through a water droplets in the atmosphere, it gets dispersed into its constituent colors, yeah, forming a rainbow. A similar phenomena is observed when white light passes through a prism. Yeah, we know that. Which color will show the maximum angle of deviation and which color will show the minimum angle of deviation? Deviation of violet is maximum and deviation of red will be minimum. Just now we have studied, right? Next, if instead of sunlight, a green colored ray is passed through a glass prism, what will be the color of emergent ray? It will remain same. Remain same. Why? Because green color is a single color, right? It won't get splitted. But in white light, there was many colors. That's why it got splitted into 7 colors. Here it is only one color, only green. So which color will be incident? The same color will be emerged out. Okay. By this, we have completed our first part A. Okay. In next part, we'll be studying about electromagnetic waves. Okay. What is electromagnetic waves? How does these waves differentiated and what is their frequency, ranges, uses, properties, and many things. Okay. Till then, keep studying and keep supporting us. Bye bye.